Okay, this is a bit of a revision on the sine rule. You should have done this at GCSE. Standard labelling of a triangle. So use capital letters for the vertices and lowercase letters for the opposite edges to each vertex. And then the sine rule is that A over sine A equals B over sine B. This is the same if you think about cross multiplying as saying that sine A over A is equal to sine B over B. You could extend that to C over sine C, but there's really no need to. The important thing about the sine rule is you're dealing with opposites. So side opposite angle. So if you're in this sort of situation here, where I know this angle is 45, this length is 5, and I want to find x, and this angle here is 60. Then I'm dealing with opposite sides and angles. Put your unknown on top. So if you want to find a length, put your length on top. I wouldn't start labelling it up A, B, C. So instead, I want a length. So the length goes on top. So x over sine of the opposite angle is equal to 5 over sine of the opposite angle. And then from there, you can just pop that into a calculator. So x will equal 5 over sine 45 times sine 60, which gives us 6.12. So on a similar note, if you're wanting to find an angle instead of a length, so if I'm in this situation here, sorry, I was going to try to make my triangles look a bit different. They're all looking a bit similar. So that's 8, that's 10, that's y, and that's 40 degrees. Same situation, angle opposite side, angle opposite side. This time I want the angle, so sine of the angle over opposite side equals sine angle over opposite side. So from there, sine y is equal to sine 40 over 8 times 10. That gives you sine y is 0.8035. Use the answer button on your calculator, but if you do shift sine of 0.8035, then y comes out as being 53.5 degrees to there. So that should be straightforward revision. You should also be aware of the ambiguous case of the sine rule. I'm hoping my recording won't run out of space. I think we'll be okay. Right, so the ambiguous case of the sine rule. So as an example, we've got triangle ABC. AB is equal to 4 centimetres. AC is equal to 3 centimetres. And and angle ABC is equal to 44 degrees. So drawing that, angle ABC is 44 degrees. There's A, B, C. So that's angle A, B, C. Gives you the angle there. AB is 4 and AC is 3. And we want two possible values of angle ACB. So angle ACB is this angle sitting in here. So this is the natural way to draw it. And using what we're just doing, you do sine of angle ACB over opposite side is equal to sine 44 divided by 3. That then you can put into a calculator, so you can times by 4, shift sign, and that gives you angle ACB is equal to 67.9 degrees. This doesn't happen on all triangles, but that angle ACB could be different to 67.9. If you imagine you've got an isosceles triangle, then this length 3 I can swing around. You sort of imagine an arc of a circle, and I could also draw in a side of length 3 like this, which I think is a slightly more unnatural way to draw this triangle. That would make this one here C, and angle ACB is now this angle sitting in here. If you think about what's happened, this is isosceles. If this one here is 67.9, then this angle sitting in here is also 67.9. And so this angle here is going to be 180 minus 67.9. So if you're in an ambiguous case of the sine rule, it really is a special case, then the angle you're finding, it could be this one here, or it could be 180 take this one, which in this case gives you 112.1. So or angle ACB is equal to 180 minus 67.9, which is equal to 112.1 degrees. So that's an example of the ambiguous case of the sine rule. But generally speaking, you won't see that very often. You're just looking at angles opposite sides to use the sine rule.